Hey guys, this is Spiral Review for Spiral 11. Starting off, we're going to do some completing the square stuff. For my first problem, I've already got x squared by itself. Check. Now I've got to get rid of my c term. So we get x squared plus 20x. I'm going to subtract 44 from both sides. Negative 8 minus 44 is going to be negative 52. Cool. Then I'm going to split up my middle term. So we got x squared plus 10x plus 10x is equal to negative 52. And I left some space because I'm going to take those two numbers, multiply them. 10 times 10 is 100. And that's what I'm going to add to both sides. So on the right side, I've got 48. And on the left side, I've got some stuff I'm going to factor. First two terms I can pull an x out of, and I get x plus 10. Second two terms I can pull a 10 out of, and I get x plus 10 left over. That's going to turn into x plus 10 squared is equal to 48. And if I take the square root of both sides, I'm going to end up with x plus 10 is equal to the square root of 48 positive, and x plus 10 is equal to the square root of 48, the negative version. To finish this off, let's subtract 10 from each side, and I've got x is equal to negative 10 plus the square root of 48, and x is equal to negative 10 minus the square root of 48. Moving on to problem 2, here we're going to complete the square again, but this time I don't have things set up quite in the way that I want. So before I divide by 6, what I'm going to do is add 10 to both sides. So I get 6x squared minus 12x is equal to 15. Now I'm going to divide all three terms by 6 so I can get my x squared by itself. And we get x squared minus 2x, and that's going to be equal to 15 sixths. Whatever, I can leave it like that, I guess, or I could reduce it into 5 halves, and that's fine too. Okay, split up my middle term. X squared minus 1x is equal to 5 halves. I'm going to multiply those two pieces. Negative 1 times negative 1 is plus 1. Plus 1, 5 halves plus 1 is going to be 7 halves because 1 is really 2 over 2. And on the right side, I can factor this, and hopefully we know at this point this is going to turn into x minus 1 squared. Cool. Square root both sides. I get x minus 1 is equal to the square root of 7 over 2, or x minus 1 is equal to the square root of 7 over 2, but the negative version. Add 1 to both sides. I get x is equal to 1 plus the square root of 7 halves, or x is equal to 1 minus the square root of 7 halves, and we're done. Moving on to the second part, first thing I'm asking you to do is to solve this quadratic using the quadratic formula. First thing I know is it needs to look like ax squared plus bx plus c is equal to 0. The big thing that doesn't work here is I have a c term that's split between both sides of the equation. I'm going to subtract 3 and get 7x squared plus 14x minus 48 is equal to 0. I know the quadratic formula is x is equal to negative the b term plus or minus the square root of the b term squared minus 4ac, all divide by 2a. And I need to know what a, b, and c are based on my equation. We know that a is the number in front of the x squared, so a is equal to 7. B is the number in front of the x, b equals 14, and c is the number by itself, otherwise known as the constant, c equals negative 48. Let's plug this stuff in. We're going to have x is equal to negative 14 plus or minus the square root, 14 squared. Please always plug this in using parentheses. If it's a negative number, that might save your math. Minus 4 times a, which is 7, times c, which is 14. I'm sorry, c is not 14. Phew, c is negative 48. I got worried for a second there. And that's all going to be over 2 times 7. Okay, negative 14 plus or minus the inside of the square root is going to be 1540, and that's all going to be over 14. This is not a reducible square root. It's not a perfect square. I could leave that as a decimal or just leave it like that. Number 4, we're on to solving using any method we want and try to use the most efficient one. When I solve a quadratic, the first thing I always try is factoring. And I try factoring because if it works quickly, and it's pretty easy for me to do. First thing to do that is I might subtract 6 to both sides to get this equal to 0. So we get 10x squared plus 20x minus 30 is equal to 0. First thing I notice is that all three of these are divisible by 10. I'm going to make my life easier and divide the whole equation by 10 to get x squared plus 2x minus 3 equals 0. How much nicer does that look? That's like going from Butterworth to me. How much nicer am I than Mr. Butterworth? The answer is way nicer because I'm not weird. Well, maybe a little bit. Okay, then we do some factoring. I'm looking for numbers that multiply to negative 3x squared and add up to 2x. Okay, I know negative 3 is negative 3 times positive 1, but adding up that gets negative 2x, or it could be negative 1 times positive 3. Adding up that gets positive 2x, that's my winner. X squared minus 1x plus 3x minus 3 equals 0. We can factor the first part. X times x minus 1, factor the second part. 3 times x minus 1 is equal to 0. I get x plus 3, and x minus 1 is equal to 0. That gets me two different equations. X plus 3 equals 0, which means x equals negative 3. And x minus 1 is equal to 0, which means that x equals 1. Those are my two solutions. And that happened to be the most efficient method because factoring tends to be the fastest if something is factorable. Moving on, we've got to simplify some exponential expressions. And here, I'm going to start by rewriting this so that my like pieces are together. So 2 doesn't have any other numbers to multiply. I'm going to keep that by itself. I've got x to the negative 3, and then I've got another x piece, x to the 4th, and then finally I've got my y stuff. I just have one of those here. If I'm multiplying two things together that have the same base, I'm going to add the exponents. Negative 3 plus 4 is going to be 1, so it's going to be 2x to the 1, y to the 4. Part B asks us to do some dividing and some powering. That's wicked exciting to me. So the first thing that I might do is see if I can simplify the inside of the parentheses first. I know that anything without an exponent, I'm going to put an exponent of 1 on. So x to the 1, 2 to the 1. The only thing that's going on here is I've got an x on the top and the bottom. And I know I need to subtract those exponents. So we're looking at x to the 1 minus negative 1, which is x to the 2, okay. And you write this is x to the 2, y to the negative 2, and that's over 2. This is all to the 4th power. I know that a negative exponent, you can kind of think of this like kind of a monkey flipping back and forth. And by flipping back and forth, I mean like spinning around this fraction bar, which, by the way, the formal name is vinculum, which means Latin, or which means line in Latin. And in doing that, I might rewrite this as x squared 2 and then y positive 2 on the bottom. Okay, and again, I'm keeping that power with a 2. And I'm doing that specifically because now I'm going to apply my exponent on the outside to each of these. I'm going to multiply by each exponent. So x to the 2 times 4, 2 to the 1 times 4, and y to the 2 times 4. My final answer is x to the 8 over 2 to the 4, y to the 8. And I could simplify 2 to the 4 to be 16, but it is not necessary. All right, moving on to some polynomial operations. Here I'm going to look for some like terms. And I like doing things in order, so I'm going to look for the highest degree, in other words, the highest exponent first. All right, 3 and 2 and 4, that's my winner. So negative 14 x to the fourth minus, and over here that's there, 10x to the fourth. Okay, that's going to be negative 24x to the fourth. Next up, I'm going to look for my next highest exponent, and that looks like 3 to me. So we're going to do minus 7x cubed minus negative 6x cubed, and that's going to be minus 1x cubed. And then finally, I'm going to look at my squared stuff. We've got 14x squared minus 8x squared, and that's going to be plus 6x squared because 14 minus 8 is 6. At this point, I am done. Part B is asking me to do some double distribution. I'm going to start with my first piece, so negative 7x times negative 5x squared. Negative 7 times negative 5 is positive 35, and x times x squared is x to the third. Okay, negative 7x times positive 6x is going to be negative 42x squared. Negative 7x times negative 4 is going to be plus negative 7 times negative 4, 28x. Negative 2 times negative 5x squared is going to be plus 10x squared. Then we get minus 12x and plus 8. Going to look for some like terms. Nothing goes with my x cubed, so we got 35x cubed. I've got a couple x squared pieces. Negative 42 plus 10 is minus 32x squared. 28x minus 12x is going to be plus 16x, and then plus 8. All right, so we're sketching a graph of a polynomial given below, and I've got to identify my x-intercept and my y-intercept. I know that I get an x-intercept by setting y equals to 0, so we got 0 is equal to 3x plus 7, which means that minus 7 divided by 3, x equals negative 7 thirds. That's a Butterworth number if I've ever seen one. So negative 7 thirds, that's going to be a little bit less than negative 2. And I'm going to label that negative 7 thirds comma 0. My y-intercept I get by plugging in 0 for x. So y is equal to 3 times 0, 0 plus 7 is going to be 7. So 1, 2, 3, 4, 5, 6, 7. And that's going to be 0, comma 7. Let me draw that line through there. And we're done. For our second one here, we're giving one with 3 different parentheses. My x-intercepts are going to happen whenever y is equal to 0. So 0 equals x minus 6, x plus 2, x plus 5. I'm going to scroll down a little bit. That means that x minus 6 is equal to 0, which means x equals 6. 1, 2, 3, 4, 5, 6. I'm going to have x plus 2 is equal to 0, which means x equals negative 2. 1, 2. And I'm going to have x plus 5 is equal to 0, which means x is equal to negative 5. So 1, 2, 3, 4, 5. Y-intercept is what happens when x is equal to 0. So y is equal to 0 minus 6 is negative 6. 0 plus 2 is 2. And 0 plus 5 is 5. Let's meet y is equal to negative 60. I'm not going to draw all those lines, so I'm just going to write a dash there and call this negative 60. Okay. The final piece of drawing this is figuring out where my smooth curve goes. And to do that, I might take a look at my leading coefficient, which in this case, none of my x terms are negative and there's no negative out in front. So that's going to be a positive leading coefficient, which means that the end behavior to the right of this is going to be on the right. Our graph is going up. So after it leaves my last point, it's going to be going roughly up. Okay, let's draw a smooth curve connecting all the dots, and we're going through that guy, going through that guy, up through him, down, and our graph should look something like this. Thanks for listening. It's been a blast.